Yeah, students, this is the new chapter called mensuration. Mensuration means measuring. The meaning of mensuration is measuring. Measuring, what should measure? We can measure the area of a triangle. We can measure the perimeter of a triangle. We can measure the area of the rectangle. We can measure the perimeter of the rectangle. This is one situation. Measuring the areas and the perimeters of two-dimensional figures. So second part is measuring the areas and volumes of three-dimensional figures like cone, cylinder, sphere, so on. So these are called three-dimensional figure. These are called two-dimensional figure. So first of all, I want to explain what is meant by solid. Solid. An object having length and breadth and thickness. So this object having two dimensions only. This object has three dimensions. Okay. So an object having length and breadth and thickness. Such object is called a solid. Okay. Cone is a solid. Cylinder is a solid. Sphere is solid. Cuboid is a solid. Cube is solid. Like that we have several. Generally, for example, this is a rectangle. Two-dimensional figure. Only length and breadth. You take another rectangle like this and join this. The figures so formed become a cuboid. Actually, I can call this a solid. Length, breadth, thickness. Length, breadth, thickness. Okay. A solid. After that, solid prism. Prism. Definition of a prism. A solid is said to be a prism. In that solid, top and bottom are congruent and parallel. And its laterals are parallelograms formed by joining their corresponding vertices. Such solid is named by prism. For example, take a cuboid. So you feel that this rectangle is a base and this rectangle is a top. Both are congruent and parallel. And laterals are parallelograms only. Actual rectangle, parallelograms only. That's why this is one of the example for prism. Prism means a solid is said to be a prism. In that solid, top and bottom are congruent and parallel. Laterals are parallelograms. Such solid is known as prism. One thing. Another is if lateral, this is lateral, this is the base. Lateral is perpendicular to the base. Lateral is perpendicular to the base. Such prisms are called right prisms. Right prisms. Right prisms. In this chapter, we will discuss only right prisms. Nana. Okay. So cuboid is a right prism. Cube is a right prism. Cylinder is a right prism. Okay, cone is not right prism. No, cone, top and bottom. Bottom is circular disc, top is a dot. They are not congruent. That's why this is not a prism. Cone is not a prism. Cylinder is a prism. See, two discs, two circular discs, parallel and congruent. So cylinder is a prism. Prism. Okay. So all the properties of the prism I will explain using this cuboid. Because already in last class we discussed all formulae for cube, cuboid, cone and cylinder and sphere. Just in this class we need to solve problems, different types of problems. Okay, but I will explain again using the object called cuboid. Cuboid. This is length, this is breadth. So this is h. Okay, understood. Or I can say this is length and this is breadth, this is height. That is better. Okay, this is the base. This is cuboid. How to find its surface area, total surface area, lateral surface area, and volume, everything. Already you know that. Just I want to write. LSA, lateral surface area of a cuboid. Lateral surface is just like a room, four walls of a room. 2h into a plus b. 2h into l plus b. Square units. TSA. TSA, total surface area. Lateral surface area plus bottom area and top area. 2 times of LB should add. So what will get? 2 times of LB plus BH plus HL. Square units. Next, volume. Volume of cuboid, already discussed, L into B into H square units. Diagonal. Diagonal of a, sir, this corner to this corner you want join. So this line segment is called diagonal. Diagonal length is root over L square plus B square plus H square units. Okay. So based on this, I will derive formulas for prism. Any prism. This is also prism only, no? I want to find LSA of a prism. LSA of a prism. LSA of prism. Now by using this, I can rewrite this. So 2 into L plus B into H I can write. 2 times of L plus this base perimeter, no? L plus base perimeter of the cuboid into its height gives the LSA. Now I can say LSA of prism is base perimeter into height. Take any prism, Nana. By using this formula, you can find its lateral surface area. Base perimeter into height. Take any right prism. For example, cylinder is taken. So cylinder also right prism only, because base and bottom are congruent and parallel. Okay, base perimeter. Base is in the shape of circle, no? Base for 2 pi r into height h, for example. So 2 pi r h is said to be the lateral surface of the cylinder. That's why any prism is given. By using this rule, you can find its lateral surface area. Lateral surface of any prism is base perimeter to height. Okay. Total surface area, TSA. LSA plus 2 times of base area, I can say. LSA plus 2 times of base area. Total surface area means lateral surface area plus 2 times of base area. Base and top are congruent, no? That's a 2 times of base area. This formula is applicable to all prisms, especially cylinder also prism only. I want to find its total surface area. Total surface, lateral surface means 2 pi r h plus 2 times of base area. Base is in the shape of circle pi r square. Therefore 2 pi r h plus 2 pi r square gives the total surface area of a cylinder. Okay. Next, volume. Volume of any prism by using this. See, LB, base area into height. So base area of the prism into height gives its volume. Take any prism, I can apply this. For example, I want to find its volume. Base area means pi r square into height means h. So I can say that pi r square h is the volume of the cylinder. So that's why using these rules you can find the lateral surface area, total surface area and volume. One thing. Next, diagonal of a cuboid is root over L square plus B square plus H square. If this cube turn to cube, for example, L equal to B equal to H equal to some x is taken. So the figure so formed is called cube. So LSA of a cube, all are equal. Now here 2x, 4x square, 4 side square. TSA, here x square plus x square, 3x square into 2, 6x square. 6 into side square gives TSA of the cube. Volume I want, volume. LBH, x cube. Cube gives the volume. Next, diagonal I want, diagonal of a cube. X square plus 3x square. Root 3x, I can say, root 3x. Root 3x is the diagonal of the cube. Okay. Okay, Rana? For any prism, especially right prism, LSA equal to base perimeter into height. TSA LSA plus 2 times of base area. Volume equal to base area into height. Okay. So units, no need to write, Nana. These are for only prism. For example, cone is given. Cone is not a prism. So that's why you can't use this formula to find the lateral surface area, total surface volume. We have another way to find lateral surface area, total surface area, and volumes. Okay. Yeah. In our class, first type solid is cylinder. Yeah, everyone familiar with the object cylinder. This is circular disc. Another circular disc. Let us assume that base radius is r, height is h. This is called cylinder. You want to say it is right cylinder means if you join these 2 points, this should be perpendicular to base radius. Then only it is said to be right cylinder. This is right cylinder. Now I want to write all formula for right cylinder. LSA I want. LSA means base perimeter 2 pi r into h square units. I want TSC, that is LSA means 2 pi RH plus 2 times of pi r square. Here I can take 2 pi r common, h plus r square units. Okay, sometimes I want to find volume. Volume is equal to base area and height, base area and pi r square, height cubic units. Okay, this is about a general cylinder. Okay, actually how the cylinder is formed, several ways I can explain. For example, this is a paper. Thickness is neglected. Length of the paper is L, breadth is B. If you fold along the length, this paper is folded along the length. I will show you how. Along the length. The paper is folded along the length. Yes, the paper is folded along the length. This is L, along the length is folded. So it will form a cylinder. This is called hollow cylinder. The cylinder formed with this paper is called hollow cylinder. Okay. So lateral surface of this hollow cylinder is nothing but length into breadth only. Okay, hollow cylinder. Thickness is not mentioned. If you consider thickness also, by using this paper, that paper is folded along the length, and this side and this side are joined. So the figure so formed is called cylinder. So this is cylinder. So if you consider its thickness, your figure will be like this, just like two concentric cylinders. This is called cylindrical shell. This is hollow cylinder. This is called cylindrical shell. To concentric cylinders. So how this forms? For example, this is a metal sheet of thickness W, just like just like looking just like cuboid, the metal sheet looking just like a cuboid. So this width is W, and along length it is folded. So this is the figure so formed. So this is called cylinder. Now this is W. No, this is W. This circumference is what? L. What is height? Height is nothing but B. So in previous diagram also, circumference is L, height is B, because that paper is folded along the length. So if the thickness is taken, thickness is considered, or this is just like a metal sheet. So just like this in the shape of cuboid is some thickness. So this sheet also folded along the length. So the figure so formed is called cylindrical shell, because this is just looking like two concentric cylinders. One thing. Okay, just with you everyone knows about a solid cylinder. So this cylinder is solid cylinder. For example, observe our chalk piece. So you can say that is one of the example for solid cylinder. Okay, this is solid cylinder. This is hollow cylinder. This is cylindrical shell. Okay. Now, how to find the volume of the cylindrical shell? How to find the lateral surface area of the cylindrical shell? How to find the total surface area of this cylindrical shell? That is important thing. So, for remaining solid cylinder and hollow cylinder is not difficult to find all, but finding all for cylindrical shell is different and difficult. I will show you. I want to draw another diagram for that. I can cylindrical shell to concentric cylinders. This is one cylinder, another cylinder, to concentric cylinders. Okay. Inner circular radius is taken as small r, outer circular radius is capital R. Okay, capital R minus small r gives width of the metal. That height is h. LSA I want, LSA, lateral surface area, that is 2 pi RH, 2 pi capital R H. Leave it. Total surface area, this is difficult Nana, finding total surface area. Outer LSA should find, inner LSA should find, and next we need to add this ring area, ring area should add. I will write 2 pi capital R H, outer surface, inner surface 2 pi small r h plus 2 times of this ring area, because bottom also another ring, no? Ring area will find here, no? Pi capital R square minus pi small r square is the ring area. I will write here 2 pi capital R square minus pi small r square. Simplify this, what you will get? That is taken as the total surface area of a cylindrical shell. Or sometimes you can write this one as capital R plus small r into capital R minus small r. Instead of capital R small r, you can W, pi W into capital R plus small r. So, said to be the area of the ring. So, 2 times of this plus lateral surface area outer one, lateral surface inner one, and added to this, you will get the total surface area. Next, volume. How to find volume? Volume is outer cylinder volume and inner cylinder volume. Outer cylinder volume is pi r square h minus pi small r square h. Here you can take pi h common, capital R square small r square. This is the formula to find the volume of the cylindrical shell, or sometimes you can write pi h into capital R plus small r into capital R minus small r, that can be written as W. So, this is the cubic unit is the volume of the cylindrical shell. Based on situations you want to find now. Everyone knows the shape, no? This is the cone. Bottom is a circular radius and top is a dot. Okay, this is called center of the base. If center of the base and this vertex is joined, this is perpendicular to the base, then you can say that is a right circular cone. Okay, so generally height of the cone is taken as h, base radius r, slant is taken as L. So, this is cone. Now, how to find its volume, lateral surface, total surface, I will explain. Okay, first of all, by using a sector, this is a sector, a paper, this is a paper which is in the shape of a sector, whose radius is I can say capital R, and length is capital length of this arc. Okay, if you fold this along L, so that this radii is coincide with this radii, so it will form a cone. I will show you. Wait, we need to join like this. We need to join these two. What happened? It will form a cone. So, what is the lateral surface of cone? Is same as the area of the sector. Everyone knows how to find area of the sector. I will show you how to find area of the sector. Area of the cone, I will write area of the cone, lateral surface of the cone, LSA of cone equal to area of the sector. Okay. Now, I want to find area of the sector. We have several formula to find the area of the sector. LR by 2, LR, one of the LR by 2, L capital R by 2. So this L becomes 2 pi r for the cone, resulting cone. This L becomes 2 pi r for the resulting cone. L equal to 2 pi r. This R, this capital R becomes small l for the resulting cone. That's why capital R becomes small l. So I want to rewrite this. Instead of L I can write 2 pi r I can write. Instead of capital I can write L by 2. 2 to get cancelled. What you got? Pi r l. So lateral surface area of a cone is pi r l. Pi into r means base radius, l means its slant height. By using this formula, you can find the lateral surface area of the cone. So total surface area you want. What nana? Lateral surface area plus base area. Base is a circular disc. Only one, no? That is pi r square. Square units. This is the total surface area of the cone. Next I find its volume of the cone. So here I am using just experimental. By using an experiment I will conclude how to find the volume. You have to do one thing. Take a cylinder and a cone. Both are hollow. Both will have same base radius, same height. This is cap R only. This is H. This is R. This is H. Okay. Now both are hollow. Assume that this is closed one side, just like a drum. Okay. Students, take water in the cone and pour it into the cylinder. After 3 times, the cylinder is with full of water. So you can say that volume of this cone is equal to 1/3 of volume of the cylinder. So volume of cone is 1/3 of volume of cylinder. Volume pi r square h. That's why now onwards volume of the cone is taken as 1/3 pi r square h cubic units. This is the volume of the cone. Okay. Total surface I can complete. Lateral surface area of the cone is completed. Okay. So what I explained about cylinder and cone. Now you want to solve some problems based on cylinder and cone. Okay students, first example problem. The radius of the conical tent is 7 meters and height is 10 meters. Calculate the length of the canvas used in making the tent if the width of the canvas is 2 meters. So I want to explain one thing. Actually the cloth that is available in cloth store is of the form. I will show you. This is the cloth roll. So this is cloth roll. Okay. Width is fixed. Width is 2 meters. This is fixed. So length you can vary. How much length you want, you can take. For example, you want 4 meter length, they will cut 4 meter length of cloth. So for the 4 meter length cloth, width is 2 meters only. You want 10 meter length cloth, you can take 10 meter length cloth. For example, they will cut it at this portion. For example, this is 10 meters. So length is 10, but width always 2 meters only. So now the question is, how much length is required here? How much length is required? So this is the, for example, length is L, breadth is 2 meters. How much length is required so that the radius of the conical tent is 7 meters and height is 10 meters. So what is what you want to calculate the length of the canvas used to make the tent if the width of the canvas is 2 meters. I think understood now. Okay. Okay students, this is a cloth roll. Okay. This is 2 meter fixed width. This is required length is L. Assume that L is a required length of the canvas. Important thing is this area of the cloth, that is 2 into L, is nothing but surface area of the conical tent. surface area of the conical tent. I will draw the diagram. This is the, for example, tent. This LSA is nothing but 2 into L only. That is important thing. This is R, say this is H, nana. So this is L. I will write TSA, not TSA, LSA. TSA, ground, they won't use cloth, no? So only LSA, I will write LSA of tent. I can say tent, conical tent, no? Here tent, I can say tent only. Equal to 2 into L, that is important. Actually, we need to write one step. L meter be the required cloth length. Okay. So L should find here. LSA, what is our formula for LSA? Pi RL. Pi RL. Don't confuse. This L is different. This L is different. I will use capital L for this. This is different. Don't confuse. Okay. You want to write one more step also. The length of the canvas required be L. Let the length of canvas that required be capital L. Okay. Pi RL equal to 2 into L. I want capital L. L is not given. L in height is given. So this is 10. Yeah, this is radius is 7. You can find L, no? Because L square equal to H square plus R square only. So H square means 10 square plus R square means 5 square. 7 square. 100 plus 49. Okay. So what is that, Nana? 149. This is L square. I want L. L equal root over 149. You know how to find the square root by using dot and bar methods. So 1 ones are 1 like that. Find out, you get 12.2. We will get 12.2, Nana. Students, now you need to substitute, Nana. Yeah. Pi means 22 by 7. R also 7. L means you got 12.2 or 122 by 10. I can write equal to 2 into L. 7 get cancelled. 2 ones are 2 11s are. So 122, 2, 4, 3, 134. So I can write 1342 by 10 equal to L. Therefore, length of the canvas equal to 134.2 what meters? Meters. 134.2 meters. So this is the answer for the problem. Okay. Next 10.1. Next one is 10.1. So that too first problem. A joker's cap is in the form of right circular cone whose base radius is 7 centimeters and height is 24 centimeters. Find the area of the sheet required to make 10 such caps. Okay, students, first of all, this is the joker cap. So neglect this one. Just we need to find a lateral surface of the one joker cap into 10 gives the area of the sheet required. Okay. So LSA of cone I can write. Is pi RL. Leave it. First of all, I want to mention what are the given circular whose base radius is 7. Base radius is 7. This is 7 given. Height is 24. L should find to find LSA. L should find. I will write here L square equal to 24 square plus 7 square. Okay. 24 is 16, 4 96, 48, 6, 7, 576, 576 plus 49. So here 5, here 625, okay, that is 625. Lateral height of the cone is 25. So LSF one cone, I can say LSF one cone equal to pi into R means what, 7, into L means 25, just now you got. So 22 by 7 into 25, 7 get cancelled, 22 into 25. Don't simplify. One important note, students, in mensuration problems, don't simplify initially. At last step we will simplify, that is important. So don't multiply, just leave it. So what you want, find the area of the sheet required to make 10 such caps. Here sheet, the shape of the sheet is not mentioned, just you want to assume that the area of the sheet is nothing but 10 times of area of each cone. Okay, area of the sheet equal to 10 into 22 into 25. Now multiply. 50 50 0 5 5, one more 0, what is that, 5 5 00. Okay, what is in centimeters? I can say that 5500 square centimeters. A sports company was ordered to prepare 100 paper cylinders for packing shuttlecocks. The required dimensions of the cylinder are 35 centimeters length or height and its radius is 7 centimeters. Find the required area of thick paper sheet needed to make 100 cylinders. Okay, just okay, but here the difficulty is what type of cylinders you want, closed or opened is not clearly mentioned. I am assuming that I want to close the cylindrical what you call the cylindrical cylinders for packing shuttlecocks. So actually, so I want to make a cap here, one cap, that also I am assuming that the cap can be made with the paper only. That's why I want for total surface area of the cylinder, total surface of cylinder, lateral plus 2 times of base area. Okay, a sports company was ordered to prepare 100 paper cylinders for packing shuttlecocks. The required dimensions of the cylinder are 35 centimeters length and base radius is 7, this is 7 and this is given as 35 centimeters. So but just I want my total surface area into 100 gives the area of the sheet that required to prepare such 100 cylinders. Okay, TSA of cylinder. Okay, base area, lateral surface 2 pi r h plus 2 pi r square. 2 pi r you can take common, h plus r. 2 into 22 by 7 into r means 7 into h means 35 plus r means 7. This 7 get cancelled. Don't simplify. 2 into 22 into this is 42. So this total surface area of the cylinder into 100. I will write in next page or here only. Total surface area. Yeah, the required area. Required area of thick paper. Sorry. paper equal to 100 into this 44 into 42 equal to, I will simplify here, yeah, 42 4 the 8 16 168 8 4 8 okay. So what I got 1848, so 184800 okay, square centimeters. So this is the area of the required paper. Okay students, here third problem, find the volume of right circular cone with radius 6 centimeters and height 7. That is not big problem, you people can complete. Now I want to explain fourth problem. The lateral surface area of a cylinder is equal to the curved surface area of a cone. The lateral surface area of a cylinder equal to curved surface area of a cone. If their base be the same, base radius is same, find the ratio of their height. Okay, so here one cylinder and cone are given, their heights are different, but base radius is same. This is r only, this is also r only. Let this is height h, this is taken as small h. Okay, find the ratio of height of the cylinder to the slant height of the cone above. So capital H is to L should find now. Okay. What is given? The lateral surfaces are equal. So given LSA of cylinder equal to LSA of a cone. So indirectly what is given? LSA of a cylinder is 2 pi RH. 2 pi RH equal LSA pi RL. Okay, so what happened here? This get cancelled, R get cancelled. What do you want? Height of the cylinder to the slant. Oh, easy. H by L equal to 1 by 2. Therefore, H is to L equal to 1 is to 2. The required ratio is 1 is to 2.